In induction and alternating current, there are 7 important question types that you should pay close attention to, since we saw 31 questions from these 7 question types in 24 JEE Main papers in 2021. So starting with the LCR series circuit in resonance with AC source, meaning that the driving frequency or the frequency of the AC source is equal to square root of 1 by LC, L being the inductance of the inductor in the circuit and C being the capacitance of the capacitor. Alternatively, we can say that the reactance of the inductor, that is XL, is equals to omega L, is equal to the reactance of the inductor XC, which is nothing but 1 by omega C. So what does it mean for the impedance of the circuit Z, which is given by square root of R square plus XL minus XC square? Well, it will simply reduce to R, the resistance of the resistor in the circuit. Also note that at resonance, phase difference between AC source and current I through the circuit, that is tan inverse XL minus XC by R, will be 0, meaning that the current and the EMF of the AC source are in phase. And as for the average power delivered to the circuit in resonance, that is I RMS square times R, it will reduce simply to V RMS square by R, and power factor cos phi, which is simply R by Z, will become 1. Using this information, you should be able to determine the unknown. But still, read through the notes and solve few questions to get comfortable. Moving on to the next question type involving LCR series circuit with AC source but no resonance, meaning frequency of the AC source is not equal to square root of 1 by LC. I would highly recommend that you go through the notes and make sure that you have a clear understanding of the impedance of the circuit Z, phase difference between current and EMF of the source, relation between RMS values of the current and EMF, power factor, and VRMS across L and C put together. With that, we will move on to the next important question type, wherein you will be given current as sum of two sinusoidal terms of the same frequency, and you will be asked to determine the magnitude and phase of the resultant current using the phasors diagram. In the next one, you will be given a coil placed in time-varying external magnetic field, and you will be asked to determine the induced current or other corresponding physical quantities. Recall that induced EMF is given by minus d by dt of magnetic flux phi b, minus sign representing the fact that the induced EMF opposes the change in the external magnetic field. So once again, induced EMF is equals to minus d phi by dt, which is where phi b is defined simply as integral of b dA. Read through the notes and see the different variations and solve a few questions to get the needed comfort level. In the following important question type on transformers, you will need to use Vp by Np equals to Vs by Ns, where Vp and Vs are the RMS voltages across the primary and secondary circuit, and Np and Ns are the number of turns in primary and secondary windings. Also, recall that assuming 100% efficiency, meaning no hysteresis losses in the transformer, power delivered by the primary windings, that is Vp times Ip, will be equal to power received in the secondary windings, that is Vs times Is. Using this information, you should be able to answer questions in this question type. But still solve good number of questions in here to get comfortable. In the next question type, you will be asked questions on charging LR circuit, in which current increases from 0 to V by R in an exponential manner, given by I is equals to I max, that is V by R, times 1 minus e to the power minus t by tau, tau being the time constant given by L by R, and represents the time when current has changed by 63%, or we can say current has achieved a value of 0.63 times I max. Now in the last important question type from this topic, here you can expect some generic questions involving induction and LC oscillations. I would recommend that you go through all the available questions in this question type to be fully prepared. With that, best wishes for questions on induction and alternating current in JEE Main.